this video is an introduction to polynomials. First question, what is a polynomial? So you may have heard the words monomial, binomial, and trinomial. Monomial is an algebraic expression that has one term in it, for example, just 2x. A binomial is an algebraic expression that's got two terms in it. Bi meaning two, as in bicycle. So binomial would be something like 2x minus 5. We've got two terms that are connected by addition or subtraction. A trinomial is an algebraic expression that has three terms in it. Tri, like a tricycle that has three wheels. And that might be something like this. Three terms connected by addition or subtraction. And then we've got polynomial. Poly means many. The prefix poly means many terms. Technically, all of the above count as polynomials. 2x is a polynomial, 2x minus 5 is a polynomial, and we use it also to represent any algebraic expression that's got more than these three terms. So x to the third plus x squared minus x minus 5, for example. We are going to dive into polynomials, learn all about them, how to graph them, how to solve them, how to analyze them. But for starters, we need to have this definition. So a polynomial function is of the form, there's a long form for you, where the exponents are all whole numbers. So everywhere I see n minus 1 here, 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 we're starting with a whole number for n. So the first exponent's got to be a whole number, not a decimal or fraction. And then each of the exponents after it decreases in value. And then it mentions that the coefficients are all real numbers. Coefficients are our blue letters, our A, our B, our C, our constant term at the end. They have to be real numbers, nothing imaginary. I would write down this definition so you have it thoroughly in your notes. To classify a polynomial by its degree and its type, talk about degree first. So the degree of a polynomial is its highest exponent. Okay, it's the term with the highest exponent that determines the degree. If the highest exponent is 0, we say that it is a constant. And you'll see this in action just in a minute. If the highest exponent is 1, we classify it as linear. If the degree is 2, we classify it as quadratic. If the degree is 3, we call it cubic. The highest degree is 4, we'll call it a quartic expression. For 5, we'll call it a quintic expression. And for 6, it would just be called 6th degree. So at this point, we stop giving them unique names. Call it 6th degree. For 7, you would call it a 7th degree, and so on. You can have up to 13, 14, 100, right? There's no end to that. So this is the degree. If you're ever asked to give the degree, you give the highest exponent, and this is the type, right? So the type corresponds to what the degree is. So if you're given a function, for example, f of x equals 3x squared minus 4, and you're asked to classify by degree and type, you would say that this is a degree 2 polynomial because the highest exponent in it is a 2, and you would say the type is quadratic, right? It's a quadratic function if you graphed it, it would make a parabola. How do I know it's quadratic? Because the degree is 2. If you're given a function f of x equals 10, there is no x in this, which means there is an invisible x that has an exponent of 0. So this is an example of a constant function. Degree would be 0, the type would be constant, and so on and so forth. So what you may be asked to do, decide whether the function is a polynomial. If so, we're going to write it in standard form, which means decreasing order of degree. And then we're going to state the degree, type, and the leading coefficient, the first coefficient on the very first term. So our first polynomial, x to the fourth minus 1/4 x squared plus 3. We're checking if all of the exponents are whole numbers, which they are, and we're checking if all of our coefficients are real numbers, which they are. So it is a polynomial function. To write it in standard form, we want to put it in order, highest exponent to lowest. It's already in that order. Our first exponent is x to the fourth. Our next exponent is x squared. Our final exponent is a 0, that's why you can't see it. Then we're asked to state the degree. The degree here would be the highest exponent, which is 4. State the type. The type is based on the degree, the list that we all just wrote down. A fourth degree is called quartic, a quartic function. And then the leading coefficient means the very first coefficient in front of the very first x term, and that's a 1, because in front of our x to the fourth, we are just multiplying it by a 1. Example B, we're checking if all of our exponents are whole numbers, which they are, and if all of our coefficients are real numbers, which they are. There's nothing imaginary here, so we need to write it in standard form. It is a polynomial. Our first term is going to be the x squared term. It's that highest exponent. The next term is the 7x term, and then the last term is minus the square root of 3. There's no exponent on that term. It's a 0. Our degree is the highest exponent, which here is 2. The type is based on the degree. Since the degree is 2, the type is called quadratic. And the leading coefficient, now that it's in order, we can see the number in front of the highest x term is pi. In example C here, we're checking to see if all of our exponents are whole numbers. We have -1 as one of our exponents. Because it is negative, this does not count as a polynomial. We cannot have negative exponents. So we're going to say not a polynomial, and we don't need to move on and answer any of the other questions. And then our final term, we've got x plus 2 to the x power. And I can see right there when I'm checking for my exponents to make sure that they're all whole numbers, because I have the variable x, I don't know if that's going to be a whole number or not. It could be negative, it could be a decimal, it could be a fraction. So we're going to have to say that this is not a polynomial either. We don't need to answer the other questions. And the final thing in this lesson, evaluating a polynomial using synthetic substitution. So here's a perfect example of a polynomial. It's all whole numbers on our exponents and real numbers for our coefficients. And if I wanted you to evaluate that function when x equals 3, the long way to do it is to replace every x with the 3 that we're substituting in. I'm showing this example, but I don't want us to use this method after today. This is called direct substitution. It's the first way you'd ever learn substituting into a polynomial function or any function. Place all your x's with a 3, and then evaluate. But there's a shortcut called synthetic substitution. Synthetic is a word in English that means fake. So this is like fake substitution. We are not going to actually substitute 3 in to figure out what this equals. We're going to take a shortcut that involves using only the coefficients of our polynomial expression. So follow along. If this is the first time you've done synthetic substitution, it's going to look a little bit strange at first, but it's really quick and it's really simple once you get used to the process. So what we want to start out by doing is the number that we're substituting in is the 3. I'm going to put in this little box over here on the left. And then I'm going to pull down all of my coefficients from my polynomial in order next to that 3. So my first coefficient is 2, because that's on the highest exponent term, right? It's on the x to the fourth term. There's an x to the third term that's invisible. It's not there, but we have to include it as a placeholder. We show 0, because there is a 0x to the third term that's missing after the x to the fourth term. Our next term is x to the second power, so we're going to include that coefficient. Our next term is the x with a power of 1. We include that coefficient. And then our last term is 8. So notice where I got all those numbers from, right? Those are just coefficients from my original polynomial. 2, the 0 that was skipped over for x to the third, the -5, the -4, and the 8. Once the problem is set up like this, you want to skip a line, skip some space underneath it, and then put a big bar as if you're about to do an addition problem or a subtraction problem. And here's how the procedure works. Step 1 is to bring down the number that's in the first location right into your answer line. Okay, the answer is going to show up down here. So the first step is just to bring down the 2. Then, each step after it involves multiplication and then addition. It's the number that you brought down multiplied by the number in the box. So 2, which is the number that we just brought down, times 3. And that is 6. It goes here. And then we add the two things together vertically, a 0 plus a 6, which gives us 6. So I just brought down a 6, and then I repeat the same process. I'm going to multiply it by the number in the box, so 6 times 3, which is 18. That goes here. And then I vertically add those two things together. Negative 5 plus 18 is 13. Then multiplication again. And then addition. And then finally multiplication again. And then addition. The final number that we end up with in the location of our answer line here is what we would have gotten if we had taken all the time to evaluate this using direct substitution. If we had taken out a calculator and plugged that all in and figured out what does it equal when you plug in all those 3's, it would have come out to the same thing that you get by doing this synthetic substitution process in the last location in our answer line. So the way that we write our final answer is to say that when you plug in 3 to the function, so f of 3, it equals 113. So when you're asked to use synthetic substitution, use this process. Do not plug in the number and take all the time to do it on a calculator. So you gotta get used to using this process. It's going to come up a lot when you're investigating polynomials in future sections. And that is all.